Ready to do the next one? Okay. Now, I want you to get your second page out. And I'm going to go back to here. And I'm going to say, oh, I might have to move this a little bit more further out. So I'm going to move these a little bit further out. Because I want to make them okay. So now let's do number 2. We now have to find the E field. So we're going to leave the same picture here. We're going to do the steps to follow. The steps to follow will also be exactly the same for number 1 and number 2. The same way we did for the force, we will divide the rod into small volume elements. We will choose the same charge element, and we will choose the same dz. Our lambda is also going to be Q over L, where Q is the charge on our length. Except for number 3, since we are not finding df, but instead we are finding E, the electric field. So the step number 3 will be slightly different, and it will give us dE equal KQ dQ over R squared. I'm going to call this B. Oh, wait, this should not be, the test chart shouldn't be there. My bad, there should not be Q's, not there. This should be K dQ over R squared, because we are now looking for dE. Step 4, what did we do in step 4? Instead of choosing the direction of the force element, we now have to choose the direction of field element. Is it going to be identical to the left? Except for of course, the F will become the E, right? So this would become DEY equal DE cosine theta. I will do the same thing, replace them. So this becomes DQ over R squared. This becomes Y over Y squared plus Z squared square root. And then may I write it exactly the same way Oh, can I just again replace dq with lambda dz? Oh, I should put this in a box. Step 5 would be to integrate to find, in this case, the total E. The total E field. And so following the same steps, it will be DEY k lambda y integration dz divided by y squared over z squared 3/2 from minus L over 2 to L over 2. Will the integration be exactly the same? Can I miss a bunch of steps? Will I then get I actually did it again. So for your peace of mind, you guys should try it again. But the steps that are being followed are identical. Right? So most textbooks will actually write this for the specific case. Well, first let's write it like this. K equals K lambda L divided by y square root of y squared plus L over 2 squared. And if you look at Griffiths, I believe he also shows you that in the limit, when L is much, much larger than y, almost an infinite line, he says EY will be written as lambda over 2 pi epsilon naught y. Try this for homework, knowing that k equals 1 over 4 pi epsilon naught. I want you to try that. Yeah. So when L is much, much larger than y squared plus L squared over 4 square root can almost be written as L over 2. Plug that in, you'll get lambda over 2 pi epsilon naught y.